Number 1. At the beginning of the school year, a school district implemented a new physical fitness program. A student project involves monitoring how long it takes 11th graders to run a mile. The following data were taken mid-year. What is the best estimate of the population mean time it currently takes 11th graders to run a mile based on the following data from a random sample of 10 students? So our best guess at the population mean, which we call mu, is our sample mean, which is x bar. So we need to find the sample mean from this data. So to find the sample mean, I need to add them all up and divide by, well, I know there's 10 of them, or I could let my calculator do the work. So in my list, I'm going to input this data here. I'm going to input this data into my list. So we have 6.5, 8.4, 8.1, 6.8, 8.4, 7.7, 9.1, 7.1, 9.4, and 7.5. Once you have your data in the list, you can hit Stat, Calc, 1var stats, and our sample mean is our x bar. Our x bar is, our sample mean is 7.9 minutes. Which means our best guess for mu is 7.9 minutes. But what we can do from this is we can now create a confidence interval because we know the true population mean probably isn't 7.9, but it's going to be around it. So by making a confidence interval, we get an interval of plausible population means. We get an interval of possible mu's, possible population means from this sample. So the student doing the project collected 50 random samples of 10 students each and calculated sample means. So he kept calculating sample means from 10 students. The standard deviation of their distribution of the sample 50 means was 0.6. So we did a simulation, got a sampling distribution, and that had a standard deviation of 0.6. What's the margin of error? Well, the margin of error is 2 standard deviations. Well, 2 standard deviations gives me a margin of error of 1.2. So my margin of error is 1.2. Interpret the margin of error you found by constructing an interval in the context of this problem. So what interval do I get? Well, my sample mean was 7.9. The center of that distribution is going to be 7.9 plus or minus 2 standard deviations, plus or minus the margin of error. So my confidence interval is, I'm going to do 7.9 plus 1.2, which gives me a lower bound. And 7.9 minus 1.2, which gives me a lower bound of 6.7 and an upper bound of 9.1. What does this interval mean? That's the key idea. Computing the interval is easy. What does this interval mean? It means we are 95% confident that the true population mean mile time for juniors is between 6.7 minutes and 9.1 minutes. So we're 95% confident that the true population mean mile time for juniors is between 6.7 minutes and 9.1 minutes. We used our interval and we interpreted that margin of error. Coach Howe gave you data for a sample of 20 student mile times and asked you to repeat the process above. What's going to happen to our margin of error? Well, Coach Howe knows, as the great statistician that he is, that a confidence interval of 6.7 minutes to 9.1 minutes isn't that helpful to him. He knows that students generally run between 6.7 minutes and 9.1 minutes a mile. That doesn't give us a small enough interval for the true population mean. So what Coach Howe did is he gave us, instead of working with 10 students, he gave us 20 students to work with. Well, when I have a larger sample size, as n increases, as our sample size increases, our standard deviation will decrease. The spread the variability in my distribution is going to decrease. Well, if the standard deviation decreases, the margin of error will also decrease. My margin of error decreases, my interval is going to be smaller than 6.7 and 9.1. The interval is going to be smaller because my margin of error is smaller. Remember Vanessa and her tips from the previous lesson. The simulated sampling distribution for the mean tip in dollars is shown below. The mean and standard deviation are given. Construct and interpret a 95% confidence interval using the simulated sampling distribution. So this is the average of Vanessa's tips. And we want to know, what's that true population mean? On average, how much money does she get from each tip? So to make my 95% confidence interval, I need my margin of error. My margin of error is 2 standard deviations. So 2 times 1.9, 2 times 1.9 gives me 0.38. Now, to make my interval, that margin of error is kind of meaningless. What I need is the interval. So I'm going to do the mean of my sampling distribution plus or minus 0.38, plus or minus 2 standard deviations gives me that 95% confidence level. 3.85 plus 0.38 gives me an interval from 4.23 and 3.85 minus 0.38. My lower bound of my interval is 3.47. What does this mean? What does this mean? What is that confidence interval there? What does my confidence interval mean? It means we are 95% confident that the true population mean of, I think it was Vanessa, of Vanessa's tips is between $3.47 and $4.23. Notice how I used a couple things here. We're dealing with population means, we're not dealing with proportions. We're not saying what proportion of our tips are bigger than $4. We're saying what's the average tip that she got. So we're working with a mean here. I use the context of Vanessa's tips, and I use units with those numbers there. I didn't just say 3.47 to 4.23. I said $3.47 and $4.23. So big idea for confidence interval. To get our margin of error, we do 2 standard deviations, because that gives us that 95% confidence level, and we add it and subtract it from the mean of our sampling distribution. And finally, number 4, a brand new hot dog claims to have a lower sodium content than the leading brand. A random sample of 10 of these new hot dogs has a mean of 314.5. A simulation was run for 1,000 trials using the 10 values in the sample of hot dogs. The results are shown below. The mean sodium content of the leading brand of a hot dog is known to be 350. Based on the margin of error for the new brand, is the mean sodium content of 350 a plausible value for the mean sodium content of the new brand? Comment on whether you think the new brand of hot dogs has a lower sodium content on average than the leading brand. That was a lot of words. But I saw the key phrase here of margin of error. I need to talk about the margin of error, so first let's find that. The margin of error is 2 standard deviations, which gives me a margin of error of 2 times 8.74. 2 times 8.74 is 17.48. To make my confidence interval, I'm going to do 314.7 plus or minus 17.48. So 314.7 minus 17.48, going down 2 standard deviations, gives me a lower bound on my confidence interval of 297.22 and an upper bound of 332.118. So what does this confidence interval represent? This confidence interval gives us plausible values for the true population mean, that parameter mu that we don't know about, of the new hot dog brand. This is the new hot dog brand. So you could write we are 95% confident that the true mean sodium content of the new hot dog brand is between 297.2, I'm assuming milligrams of sodium would make sense, milligrams, to 332.18 milligrams of sodium. So the leading brand has an average of 350 milligrams. The leading brand has an average of 350 milligrams. Does this new hot dog brand actually have a lower sodium content? Well, we don't know if it actually does, but our confidence interval gives us some statistical evidence that says it probably is lower. Because 350 is not in our interval, we have statistical evidence. We have statistical evidence that the new brand has, on average, a lower sodium content. So because 350 is not in our confidence interval, we do have statistical evidence that supports this idea that the new brand, on average, has a lower sodium content. Because our plausible values for that true population mean, the possible values for that population parameter fall within that, we're 95% confident that it falls within that interval there. So, big idea, margin of error is 2 standard deviations to make our confidence interval, which gives us these plausible values for that population parameter we want to know so much about, is the mean of the sampling distribution plus the margin of error, the mean of the sampling distribution minus the margin of error.